Next WOW video, it's part 284C3K25. Line 22f1fa19c3k25. Higgs Boson Field Symmetry QCD Michael Birse Wow Seti. There's the alien radio signal there, and this is Higgs field conceals symmetry Google. Researching what the word means. Just so you know, I did a whole section of Higgs videos that are separate from the WOW video, but I did a cross-referencing with them after reading some of the articles from Science News. So you want to take a look at those. They were all blogged between September and November of 2012 on my channel, The Idea Girl Says YouTube. Okay? So October 23rd is when I was working on the research for the video, and today is November 19th, 2012 when I'm filming it. So this is a quote from Professor Michael Birse. He's his research. I found it online, okay? So research interests. I work at the intersection between particle and nuclear physics. In particular, I'm interested in the role played by the symmetries of quantum chromodynamics, or QCD, in the structure and interactions of nucleons and mesons. The most important of these symmetries of the strong interaction is chiral symmetry, which is respected by up and down quarks, the ones we are made of, because they have very small masses in QCD. The strong attraction between quarks and antiquarks means that empty space is filled with a Bose-Einstein condensate of quark-antiquark pairs, which acts like a Higgs field and hides the chiral symmetry. My work takes advantage of the way pions, the lightest mesons, remember the symmetry in their interactions. It makes use of a range of theoretical techniques using effective field theory and the renormalization group. I'm also interested in transitions from ordinary nuclear matter to new phases, such as quark, gluon plasma, or a color superconductor. The plasma is the phase of matter which existed shortly after the Big Bang, and which may be recreated by colliding heavy nuclei together at ultra-relativistic energies. Color superconducting quark matter may exist at very high densities in the center of neutron or quark stars. So that's from www.manchester.ac.uk, and that was June 25th, and I'm not sure. It was these two guys chatting online, and I found it from a physics site here, physicsstackexchange.com. So this is a Warwick's comment from Göttingen, Germany, and Mazzaruda from London, United Kingdom. Okay? So he asked, and I guess Warwick answered. Quote, to oversimplify, the Higgs field has 4 degrees of freedom, 3 of which interact with the W and Z bosons and generate masses. The remaining degree of freedom is what we see at the 125 GeV Higgs boson. In a sense, the Higgs boson that the LHC is about to discover is just what's left over after the Higgs field has done its work. The Higgs boson gets its mass from the Higgs mechanism, just like the W and Z bosons. It's not the origin of the particle masses. The Higgs boson doesn't have 0 rest mass. So that's physics from stackexchange.com. Quote, does this mean there is some kind of self-interaction? So this is the questions going on between these two guys in this forum. Okay. So yes, the Higgs field is self-interacting, and to extent I understand it, it is the self-interaction and particularly its form that allows the Higgs field to condense by giving the lowest energy states of the field in a non-zero expectation value. But the Higgs field have electroweak charge. So essentially, space, when the Higgs field is in a ground state, is an electroweak superconductor that breaks, hides, screens the electroweak symmetry down to the observed electromagnetic symmetry. In addition to the electroweak gauge field, interactions with the Higgs field, the fermion matter fields also couple to the Higgs fields via a so-called Yukawa interaction, which is in the standard model the origin of matter's mass. So it's from physicsstackexchange.com, question and answers. Okay? I guess the question was, how does the Higgs boson gain mass itself? Okay, so thanks for watching. We'll go on to the next video.